In this video, we will find common denominators, fractions. Finding common denominators is the starting place for adding and subtracting fractions. So let's say I have a model. This model is showing me thirds. I'm going to highlight 1/3. Quick review of what this fraction means. This bottom digit here is the denominator. The top digit is the numerator. The denominator of a fraction tells us the size of the pieces. So looking at this fraction 1/3, the size of the pieces are thirds, and the numerator tells us how many of those pieces we're describing or how many we're talking about. So in this case, we're talking about one piece. It's the size of a third. Over here, I'm going to draw another model. This model is showing us fourths. I have shown here 1/4. There's one piece that I'm describing or talking about. The size is a fourth. I have my two fractions here, 1/3 and 1/4, and I want to find a common denominator. What that means is this piece is the size of a third, this piece is the size of a fourth. I want to make all these pieces the same size. I want them to have the same denominator. One way that I can do that is I can come over here to this third, and I'm going to partition this model into fourths. I'll partition that in half, and then half those halves. And then I'm going to come over to my fourth and partition it into thirds. Now I have the same sized pieces. Notice that my whole, the rectangle that I started with, is the same size. Now, it's not perfect because I'm a human and I'm drawing it, but it is accurate. We're talking about the same sized whole here. So now I can still see this blue underneath. That is still showing me 1/3 of the model, but I have partitioned it into smaller pieces. So now I'm looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. All the pieces are the size of 1/12, and 1, 2, 3, 4 of them are shaded in. This shows me that 1/3 is equivalent to 4/12. Likewise, over here with my 1/4, I can still see that pink fourth shaded in, but now it's been partitioned into smaller pieces. There are 12 pieces total, so they're all the size of 1/12, and there are 3 pieces shaded in. This tells me that 1/4 is equivalent to 3/12. So now we have found a common denominator because all of these pieces are the same size. Let's try another example. Let's look at these two fractions. I have 2/3 and 5/6. So I'm going to show you the same way that we did before. So here I'm going to partition this model into thirds. This denominator told me how many pieces there would be in the whole. It's telling me the size of the pieces. They're the size of thirds. And the numerator is describing how many pieces we are talking about. So I shaded in 2 of those thirds. Now for 5/6, I will partition into sixths, partition that in half, and then third those halves. The denominator tells me the size of the pieces. They're each the size of a sixth. Now I'm going to shade in 5 pieces because that's the amount that we are describing. So here are my fractions, 2/3 and 5/6. To find a common denominator, I'm trying to make them all the same sized pieces. So one way I can do that is over here on my thirds, I'm going to partition it into sixths. And here on my sixths, I'm going to partition it into thirds. I haven't shaded anything else in. I haven't erased anything. This is still showing me 2/3, and this is still showing me 5/6. I've just partitioned them into smaller pieces. So let's look and see what happened. I started with 3 pieces total. They were the size of thirds. Now I'm left with 3 rows of 1, 2, 3, 4, 5, 6. I'm left with 18 pieces. Each of those pieces are the size of 1/18. When I look at the ones that are shaded in, I had 2 pieces shaded in, or 2 rows shaded in. Now I have 1, 2, 3, 4, 5, 6. I have 2 rows of 6. There are 12 pieces shaded in. Looking here at the 5/6, well, I started with sixths, 6 pieces, and when I partition those into thirds, now I have a total of 18 pieces. They're each the size of an 1/18. Looking at the ones that were shaded in, my numerator here, my numerator was 5. There were 5 columns shaded in, or 5 pieces. Now, as I look, I see 1, 2, 3 rows with 1, 2, 3, 4, 5 in each. There are 15 pieces shaded, or 15 that I'm describing. I have 15 18s. These fractions are equivalent. 2/3 is equivalent to 12 18ths. 5/6 is equivalent to 15 18ths. So let's look at what's happening numerically, or just with the numbers. We had 3 pieces total. Now we have 1/18ths. We multiplied the number of pieces by 6. There were 2 pieces shaded in. Now there are 12. We also multiplied the pieces shaded in by 6. Look what happens here. We have multiplied 2/3 by 6/6. And if you notice, 6/6 is equal to 1 whole. This is the identity property of multiplication. We know that anything times 1 is itself. So we're taking 2/3 and multiplying by 1. This 12 18ths is equivalent. Let's look and see if the same thing happened over here with the 5/6. We had 6 pieces total. Now we have 18. We've multiplied the number of pieces by 3. The numerator, we had 5 pieces shaded in. Now we have 15. That was also multiplied by 3. So we have multiplied 5/6 times 3/3. Again, 3/3 is 1 whole. 5/6 is equivalent to 15 18ths. When finding common denominators, we can always use the opposite denominator to help us out. So notice, we started with thirds. We multiplied by sixths. We chose 6/6. Here we had 6, and we multiplied by 3/3. We used the opposite denominator. But that's not the only common denominator between thirds and sixths. We can create equivalent fractions by multiplying by any digit, as long as we do the same thing on the top and the bottom, because that will make 1 whole. I'm going to rewrite my fractions down here. I have 2/3 and I have 5/6. Over here, I'm going to list the multiples of these numbers. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. I'm going to stop there because we've already shown that I can use 3 times 6 and I can get a common denominator of 18ths. Here are my multiples of 3. Now I'm going to list my multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. Again, I'm going to stop here. I'm looking at my list of multiples to find common multiples. I see that they each have 18. Ooh, they also both have 12, and they have 6. Which means that any of these denominators could be my common denominators. We've already seen that we could create 18ths. What if we chose 12ths? I'm going to write my new denominator of 12ths, and I'm trying to make equivalent fractions. I'll write my equal sign. Then I'm thinking, 3 times what gave me 12? Well, this was 3 times 1, times 2, times 3, and times 4. 3 times 4 is 12. To make it equivalent, what I multiply by on the bottom, I must also multiply on the top. So 2 times 4 is 8. 2/3 is equivalent to 8/12. Now coming back over here, to make this 5/6 into 12ths, 6 times 2 equals 12. And what I do on the bottom, I must also do on the top. 5 times 2 is 10. So 5/6 is equivalent to 10/12. We have shown 18ths and 12ths. Let's look at these sixths. I'm going to use the common denominator of 6. So I'm going to go ahead and write it here. 3 times 2 gave me 6. So I will do times 2 on the top as well. 2 times 2 is 4. 2/3 is equivalent to 4/6. Over here, look at the 5/6. I already have sixths here. So I really didn't change anything at all. I could write that I use times 1 and do the same thing on the top. 5 times 1 is 5. I didn't change anything. In general, our best option is going to be to use the least common multiple to find the least common denominator. Here, I could keep going and I could find lots of common denominators between 3 and 6. But my best bet is going to probably be using the least common multiple. In this case, it's 6. I didn't have to change this 5/6 at all. This is the most efficient strategy. Let's look at a few more examples. Here I have 2/5 and 1/6. This time I wrote them on top of each other. It doesn't change anything. I just wrote them in a different location. I'm going to write their equivalent fractions out to the side. So as we saw in our models, I know that I could use my opposite denominators. So I could take this denominator of 6 and use it up here and multiply 2/5 times 6/6. And likewise, I could use the denominator of 5ths, pull it down here, and multiply 1/6 by 5/5. But I want to know if that's my best choice. I want to try to find the least common denominator. At quick glance here, I know that I can't multiply 5 times anything to get me sixths, and I can't multiply 6 times anything to get me fifths. So I'm going to go off to the side here, and I'm going to list my multiples. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. I'm going to stop there at 5 times 6 because I know that will get me a common denominator. I know 30 is a common denominator. I'm just looking to see if there's anything smaller. Now I'm going to list the multiples of 6. I've got 6, 12, 18, 24, 30. That's times 1, times 2, times 3, times 4, and times 5. As I look here, I see that they have 30 in common, but there is nothing else smaller. So 30 is my best choice. 30 is the least common multiple. I'm going to come over here and write my new denominator of 30ths. I like to go ahead and write my common denominator on both so that I remind myself my whole goal here is to make them the same sized pieces to make them 30ths. Then I get to be kind of like a detective and figure out what this numerator should be. I'm going to go ahead and write my multiplication sign here. And I'm thinking 5 times what equals 30? And if I didn't know that 5 times 6 equals 30 off the top of my head, I'm going to go back and look at my multiples because I've already done all of this multiplication. This was 5 times 1, times 2, times 3, times 4, times 5, and times 6. So I'm going to multiply this denominator 5 times 6. And if I do that on the bottom, I must also do that on the top. 2 times 6 is 12. So 2/5 is equivalent to 12/30. Now moving down to my 1/6. Now I'm going to be multiplying here to find this common denominator. And I know that 6 times 5 equals 30. And if I do that on the bottom, I must also do that on the top. 1 times 5 is 5. 1/6 is equivalent to 5/30. Remember, it is incredibly important that we are multiplying our fractions by the same thing in the numerator and the denominator. Same thing in the numerator and the denominator. That way, we are keeping equivalent fractions. We're just multiplying by one whole, and we know that anything times 1 is itself. For the next example, I'm going to use 5/8 and 3/4. I know that I could use the opposite denominator. I could multiply 5/8 by 4/4. I could multiply this 3/4 by 8/8, but I want to know if that is the best choice. If you don't see something off the top of your head, come over to the side and write out your multiples. I know 8 times 1, 8 times 2, 8 times 3, and 8 times 4. Here are my multiples of 8 all the way to times 4 because I know that I could do that and make a common denominator. I'm going to start listing the multiples of 4 now, and I'm just going to stop as soon as I get to the first thing that matches. 4 times 1 is 4. Nothing matches yet. 4 times 2 is 8. Ooh, this matches. There's 8 on both sides. So I'm going to stop. My least common multiple is 8. So I'm going to use that denominator. Looking at my 5/8, it's already 8ths. So I'm not going to change anything at all. They're already the same size. Moving down to my 3/4, I do need to change this denominator to make it 8ths. In order to do that, I must multiply 4 times 2. And if I multiply the denominator by 2, I will also multiply the numerator by 2. 3 times 2 is 6. So here's a really great example of how we should look for the least common denominator. If I had used the opposite denominator, if I had multiplied by 4/4 here with the 5/8 and multiplied by 8/8 down here at the 3/4, I would end up with 30 as my size pieces. Those are really small pieces. And for some problems, that might be okay. But in general, we want to look for the least common multiple. Let's do one more example. Here I have 3/10 and 9/8. Again, I'm thinking to myself, I know I could use the opposite denominator. If I were to do that, up here it would look like 10 times 8 would give me 80ths. And down here would be 8 times 10. That's also going to give me 80ths. But I'm thinking that's a really large value. Tells me that those pieces are going to be really tiny. 80ths. 80 pieces in that whole. I want to know if there's anything better. So over to the side, I could list my multiples of 10 really quickly. 10, 20, 30, 40, 50, 60, 70, 80. And I stopped at 80 because I know I can use 10 times 8. Now I'm going to go over and list my multiples of 8, and I'm going to stop as soon as I find something they have in common. Oh, I see it. Here's 40, and here's 40. 40 is the least common multiple, so I'm going to use this as my common denominator. Okay, I'm going to have to change the size of the piece of both of these fractions this time. So again, I know I'm going to have to multiply to get this common denominator. 10 times 4 gave me 40. And 3 times 4 equals 12. 3/10 is equivalent to 12/40. With the 9/8, going to multiply the 8 times 5. So also multiply my numerator times 5. 8 times 5 gave me 40. 9 times 5 equals 45. 9/8 is equivalent to 45/40. Think back to our first examples where we're using the models. If we were to model 3/10 and 9/8 and then use the other denominator to partition these, we would end up with 40ths, 40 pieces in this whole. Those would be really, really tiny. Models are great to prove our thinking, but when we get to fractions that are a little bit more complicated, we need to know how to do it numerically. Remember, you can always use the opposite denominator to find a common denominator. Here, on this example, 2/3 and 5/6, we use the opposite denominator to multiply and get 18ths. And that worked perfectly fine. We have common denominators with the same size pieces. But we also see that there are other common denominators that we could choose. In general, you're going to want to find the least common multiple to use as your denominator.